The Arctic is heating up faster than many other places in the world. And so we want to work there to look at the response of the environment to these rapid changes.
Barter Island sits at the top of the Arctic National Wildlife Refuge at 70 degrees north latitude, just 70 miles west of the Canada border. On this tundra island reside nearly 250 residents in a remote Alaskan village most have never heard of, called Kaktovik. The weather here can be inhospitable at times. The year's average temperature is below freezing, which can make working outside pretty difficult. Yet the greater challenge can be in just getting to the island. The fog around Barter can mean days and days of delayed flights, waiting around at the airport, and many trips hauling gear back and forth. So the scientists are clearly happy when they're finally on their way. USGS researchers want to know what's making bluffs erode so quickly along the north slope. Is the treeless frozen land, or permafrost tundra, thawing faster and deeper as Arctic temperatures warm? And if so, is that thawing helping to speed up erosion once the storm waves hit? Is the shrinking sea ice also part of the problem?
What we've seen these last few years is a lot of melting on the actual bluff surface, creating small streams. In our most recent trip, we were there for 4 or 5 days, and the size of the streams, we could visibly see them growing.
They also gather other bits of data for a wider view of what's changing in the Arctic and what's triggering it. In some places like Drew Point, Alaska, nearly 20 meters of bluffs can erode in a year. In Kaktovik,
erosion rates there are fairly moderate, averaging about 1.3 meters a year for the tundra bluffs. But it's punctuated by storm events where in a single storm you can get several meters of erosion.
So they snap photos of the coastline from planes, they measure how much the shoreline has shifted the past 60 years, and they use time-lapse cameras to capture big storms and erosion along the bluffs.
We're also coring to look at the internal geology of the bluffs. We work with local Inupiats in their boats. We'll also work with the locals using ATVs. We've been collecting repeat photography of the bluff face along Barter Island so we can actually look at specific changes through time.
Peter Swarzinski and Cordell Johnson also test how electricity flows through the icy ground, which tells them how the permafrost is constructed.
The surface is actually really complicated. How consistent is a permafrost as you go down or across the surface? It's not a simple layer frozen sediment. And then we can run chemical analyses. For example, what the salinity of the permafrost is at depths. How old is the permafrost at 1 meter or at 2 meters or at 5 meters?
More trips to the area are planned to resolve how the water flowing beneath the permafrost, called groundwater, can influence erosion.
If 10 meters are being eroded every year, you want to know what this place is going to look like in 10, 20 years. And so knowing something about how fragile these coastal bluffs are is really useful.
Cordell does barter. Scene one, take one, that's a wrap.